Hello guys, welcome to Courage's computer classes once again. How are you? Hope you guys are doing extremely well. Right? So till date we have discussed arrays, concept of arrays, integer and we have worked with lot of numbers calculations, right? See, today I am going to start with strings. So before starting, we need to know about one particular data type, that is character data type. See, till date we have actually done a lot of program on number systems, right? Number programs, how and what is an Armstrong number, Dyson number, etc., etc. So now, from today onwards, we'll be working with alphabets basically. Strings are basically words, combination of characters. Okay. So before starting with strings, we need to know about characters. What characters are? See, for characters, we have a character data type in Java, that is char. Okay, it specifically takes around 1 byte. I can take any alphabet here. Okay, so char ch is equal to A, char ch1 is equal to B. Right, you can take it like this. Fine. That means in character variable we can store only one letter at a time. Alphabet is actually the set of letters A to Z. Okay, this misconception we mostly have. A character we can store only one letter at a time, or even the numbers. Even the numbers can also be stored as character. I can also store char some say ch3 is equal to 1. Okay, I can store it. No issues in that. See, all the characters or all the letters you are having that you see in your keyboard, the standard input device, all of them are actually basically characters. So for our use, we sometimes use them as a number or a digit or an integer, and for sometimes for our need we can use them as a character. Okay, see, when we don't want to make 1 plus 2 is equal to 3, at that time, see, when we are doing this, when we are calculating the sum of two numbers, we are treating 1 and 2 as a number, getting my point, as an integer, right? But when you are not making any calculation using these numbers, you are storing serial number, say serial number, and the serial number are saying 1, 2, 3, 4. This time you are not making any calculations, it is just here you have some topic and you want to store some topic here. That is why you are storing that at serial number 1 this topic comes, at serial number 2 this topic. So at this point of time you don't want to make any kind of calculations, rather they are working like a label. So at this having the topic 1 is having the tag topic 1, serial number 1, right? Or you can consider a page number in the book, same. So those are that point of time we can use them as characters, right? So everything that we are having, including the special character, dollar, hashtag, asterisk, all are characters, right? So characters are basically letters or numbers or special characters including. Even a blank space is also a character. A blank space is also a character. Fine. That is why in password we use a combination of letters, numbers and blank spaces also sometimes, right? So those are characters. Now characters are A, B, C and all, and also a number. See, numbers can be stored, but I have a question. See, when I've started the basic concepts of programming, I mostly used to say, see, computers understand binary language. That means ones and zeros. Ones and zeros. Alright? Ones and zeros. So, if I am writing char ch is equal to A, or if I am storing char CH, capital C is equal to capital A, I mean A in uppercase, and when you can store other alphabets. So how is computer storing this? How is the system storing this? Because see, A is not a number, right? That we can convert it into binary. Then how is the system storing them? Just pause the video and think for a while. Ready? So we have a concept called ASCII values, ASCII characters. Okay. So this standard estimation assigns some values to all your characters that you are having in your keyboard. Okay. So capital A starts from 65. Capital B is 66. Right. Similarly, C is 67. Dot 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 to Z, it is 90. Fine. Similarly, small a is 97, starting from 97. Okay. B is equal to 98. Okay. And dot 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 small z is 122. Right. See, actually what is happening, system is converting these numbers into these ASCII values into its equivalent binary form to store the characters. Fine. So 97, you may have a question. See, after 90 you have directly started from 97 in small a. In between 90 and 97, from 91 to 96 there are other characters stored, right? ASCII values, we have 128 ASCII characters. Okay, 128 ASCII characters for a system. So from 1, I mean serially 0 to 127, there are a lot of characters, and that includes even special characters like the dollars also have some ASCII value. In Google, if you do a Google search, you can easily find the ASCII table for that. In our program, we don't need all of them. We just need to know the ASCII values of the numbers. The alphabets, characters, and also the ASCII values of the numbers, the digits. Okay, from 0 to 9. See, 0 has an ASCII value of 48. Okay, 48. 0 ASCII 48. Then 1 is 49 most probably, and dot 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 up to 9 we have, it's around you can say 56. Is it 56 or 57? Let me see the calculation. From 0 I have started, so 0 is 48, 1 will be 49, 2 is 50, 3 is 51, and so on. So before this we have somewhere 47, and we are writing here 10, so it can be 57. Okay, it is 57. So from 48 to 57 we have our ASCII values for numbers. Okay, and these are, remember, these are acting like characters now. 0 is not a number now. Okay, 0 is not a number, we are treating it as a character. Fine. So this was the concept all about characters. Okay, and you can perform many operations with characters also. Those we will be discussing along with the strings. Okay, see, strings and characters, they are like siblings to each other. Now more than one characters form a string. Fine. Even a word is a string, and a whole sentence together is also a string. Okay, fine. So that was it. Now let us come to the strings now. Okay, this was all about the characters. Now if I see, character is a data type in Java, right? Character is a data type like integer, double, float, etc. Now strings, I can write a word. See, unlike characters, if I am writing, character can hold a single alphabet or a digit, char ch is equal to a, you can write. But if I am writing a string, okay, another thing, a single character can also be a string. So you can make a note, every character can be a string, but no string can be a character. Let me discuss to strings uh, strings start with double quotes, okay, inverted comma, basically you can say double quote open, and then you can write a string. Say I'm writing my name here only, and double quote close semicolon. Also, a string can have a single character, okay, say s2 is equal to a. Fine. So there is a difference between this and this. Actually, if I am talking about a single character, this character actually ends with a single quote and closes with a single quote, okay, single inverted comma. But this, if I talk about this, a string should start with a double quote and end with a double quote. This represents a string, okay. And that is, as I said, a single, therefore a single character can also be treated like a string. And now, so how are they different? Actually, in character, if I store characters, actually stored in ASCII values, okay. In strings, if I say each of them is a character and each of them separately are stored as using their ASCII values, okay. Fine. So this is a concept of string. String is a combination of characters, and it can also be a single character, but if it has a double quote, then it is a string. Fine. Now, if I talk about string, string is not actually a data type. Character is a data type. That is fine. Character is a data type. But string is a class. Actually, this char is a data type. Character is also a class. Char comes from the character class, okay. Even when we talk about int, int comes from integer class. Yes, so int comes from integer class, and int is basically like an object of the integer class, okay. So for string we have no such objects. Like for integer class we use an object int, okay, and for character we have this char data type as. Now string has no such object. String is itself a class. And we are creating an object of the string class. Basically you can treat it like a variable only, but that is actually an object. When we are writing string s is equal to origin, then it's actually s is an object, okay, object of the string class. And under that string class we have a variety of functions that we'll be discussing today. Fine. So now character is a data type, string is a class. That's absolutely fine. And so this was the basic terms about string and how actually strings work. See, there is another concept we know, that strings are immutable, that you must know. Immutable means strings cannot be changed. Now that doesn't mean you cannot say that if s is equal to origin, then you cannot replace it, you cannot delete it and write another thing that a or d, something like that. That's not I am saying. But what I am saying is the value, like in other variables, what happens in case of string. If you say I have initially I am everything works under stack, so I am having a stack, and under that stack I am having s. Now initially say I have stored origin, okay, fine. So there is something called a heap memory. When you are writing origin, there is a value coming origin, sorry, in capital I have written, so here it should also be capital. origin. Fine. So as like every variables, there are stack. In stack we have the variables, right? So this s will be pointing to origin, fine, in the heap memory. Now in other variables what happen, like say I am writing int a is equal to 10, int a is equal to 10, fine. Then when again you are writing int e, like when I am storing a is equal to 10, this is a box and then 10, but again when you write 11, basically this 10 gets overwritten by 11, right? But in case of strings what happen, basically when once you have written origin, that is stored in the heap memory, right? Now when you are again writing ard, okay, ard, now this doesn't get overwritten, origin doesn't get overwritten. Rather what happens, here you get another string called ard that comes to the stack, I mean heap memory. This is your heap memory, fine. And the s from the stack memory is pointing, will now point to the particular ard. Basically this pointer is changing. This value is still in the memory, this origin is still in the memory, right? And it is acting like a garbage value now, fine. It is acting like a garbage value. So actually Java garbage collector will actually remove this. There is a concept called Java garbage collector, feature of Java that basically removes garbage, fine, which actually helps in like efficient use of memory. Because if you have useless things, because this is no useless, you have no such strings now presently, so Java garbage collector will clean this garbage. But in other programming languages, if I talk about, so basically this is how it works, and this will remain as a garbage, fine. Okay, so clear, this much is I think I hope it is clear to you. Now see, this can be made more clear. Say if I am writing string s is equal to, say apple, fine, apple, fine. String s2 is equal to also apple. Now so here is s and here is say s2, fine. This is an apple, and s is pointing to that variable, fine. Also I am also making it better. Say if I am writing s2 is equal to say s, okay, s2 is equal to s, so s2 basically will be also pointing to the same apple. s2 is equal to s means the same thing, that is apple. Actually the thing what happens, if I am creating s2 is equal to apple, it will also create another apple here. If I am writing s2 is equal to apple separately, it will create another apple here separately in the heap, and s2 will point to that apple again separately, okay. So but when you are writing s2 is equal to s, then basically the s2 is also pointing to the same apple, fine. Now but the thing is that in case of normal variables, in other data types, if I talk about, say not other data types, string is a class, not a data type. In case of data types, int a is equal to 10, int b is equal to a. Make it clear, b if a is having 10, this value is just copied to b, okay. It is not that it is the same object, I mean same literal that both the variables are pointing to. 10 is just simply copied to B. Fine. Value from A is simply just copied to B. But in case of strings, both will point to the same literal. But see, even after that, then again if you change the value of S2, I am again in another line writing string S2 is equal to say mango. Now what happens, this will, as strings are immutable, even after I am changing the point, I mean value at S2, it will not affect S. Fine, it will not affect S. Rather what will happen, this pointer from S2 will be gone and a new literal will be created here, mango, and S2 will be pointing to that, and S as it is points to apple. Fine, yes or no? So this is how actually it will work. Fine. So this was about how strings work and why strings are immutable. Fine. Clear up to this it is? I hope it is clear. Okay. If not, you can just repeat the video and watch it from up to this length. Okay. Now let us directly jump to the functions of the string class, because see there are many other factors that work on inside the memory related to strings, so that will make the video long rather than and you will be bored. So rather than making the video long, I will be discussing them separately in a separate video. Okay, let us just now jump to those parts which are essential for writing a program using the strings. Okay, so let us now talk about some basic functions in the string class. See, when we are dealing with strings, we'll be dealing with mainly three classes. First, the string class, essentially the string class. Then we will be having string buffer class, and the string tokenizer class. Fine. So in today's lecture we'll be specifically talking about the string class only, and string tokenizer class has not more than 2 to 3 functions that I will be discussing in upcoming videos. String class and the string buffer class, these are the most important functions if I talk about, specifically for ISC appearing 11th and 12th students. Okay, and there are many other things that that are required for first year or second year BTech course. Okay, now but for 11th standard, 12th standard, this video will be enough for string class. In string buffer class I will be bringing up in another video. Okay, so string class today, string class. Okay, this is string class. Now for string class you do not need to make any separate any objects. First few functions let us see. So we have some functions called to uppercase. Okay, to uppercase, to lowercase. Just note down the functions, then I will be discussing all these. To lowercase. Okay, then we have index of, we have last index of, fine. We have dot caret, fine. So these are the basic functions that we'll be using these functions we can do most of the programs. And in actually the string buffer class that we have, there's a modification. We have certain functions that makes our work much more easy. Okay, like to reverse a string, we can just do with a single function dot reverse that we have inside the string buffer class. Okay, so this was just an example. Now let us first today discuss about these functions. Okay, first one is to uppercase, dot to uppercase. By the name itself tells that dot to uppercase, what will it do? It will actually convert your lowercase letters into uppercase. In strings, if you have any lowercase characters, it will convert all of them into its uppercase form. Fine. And the characters which are already in uppercase, or if any character is digit or number, those will remain unaffected. Fine. So say I'm make you understand with an example. Okay, so say string str is equal to, I am writing say origin. Okay. And the return type of this function is also string. Note it down, return type of the function is also string. Okay, is also string. It returns a string only to you. So if I write string in another variable, I am writing say string str2 is equal to str, this variable name which you want to change, dot to uppercase, dot to uppercase. Fine, str dot to uppercase. Okay, in your functions, actually note down another function. There we have another function called compare to. Okay, compare to. Okay, those I will be discussed. Those are comparison functions. For now, see dot to uppercase. What will it do? See, A is already in uppercase. It will convert R, I, J, I, T, all these remaining letters into its uppercase form. So if I talk about str, the value in str2 will be, what will it be? It will be capital A, R, I, J, I, T. Fine. So the opposite thing will be done by the lowercase, dot to lowercase. So if I am writing string str3 is equal to my students. Okay, so and I am writing string str4 is equal to str3 dot to lowercase, So what will it do? It will ignore this blank space also. Just it will convert if if any alphabet is there in uppercase or not. If it is in uppercase, convert them to lowercase and keep other things unchanged. Okay. So it will be turned into lowercase. It will be written as my students, small s, Tutents. Fine. That was all about two uppercase and two lowercase. As simple as that. You can use it as it is. You can use it as it is. Fine. Then what we had? We had dot index of. Okay. So two uppercase and two lowercase. I think it is clear to you. So dot to uppercase and dot to lowercase. Fine. Next we have dot index of. Fine. dot index of. So index of, as the name suggests, it will return you, it will take an argument here, okay, a parameter here, say parameter 1, basically a character type variable. Fine, any character, okay. So dot index of will return the index of this character passed here to the variable where you are storing it. Or it also, you can say, it can also be written as dot c index of ch comma index. Note down these four forms of index of: dot index of str comma index, or dot index of str. Fine, str. So see, dot index of ch, what will it do? It will actually pick out the character, index of a single character. If I am writing string as is equal to my, not my, say I am writing Myanmar, okay, Myanmar. Fine, Myanmar, say something, I can say is Myanmar is a, say, what to say, yeah, it is a country, okay. I am taking out, random string, okay. So if I write is, dot index of, you need to write it as you need to pass a character. If I write m, and the return type of index will be an integer, the return type is integer, it will return an integer because the index is an integer, right? It will return an integer value, and I am storing it in some integer, therefore say int I is equal to. So what will I store? So as you can see, now there are two m's, okay. So in Myanmar I have two m's in whole of this sentence, throughout the sentence I have two m, okay. So if I write Myanmar, then the first appearing m, index of the first appearing m will be returned to I. Fine, will be returned to I. So what will be the value of I? I will be equal to 0, because see, it is 0, 1, 2, 3, 4, 5, 6, and then blank space is 7, and so on. The index is continuing up to the end of the sentence. So m is 0. Now if you want to the index of this m, okay, the second m, you actually need to write any value. That means, see, basically if I write m comma 1, that means I am saying find me out the index of m which is appearing after index 1. So this basically means, this ch means index after, after this one index, wherever m is present, return me that index. Even if you write 0 also, no problem, okay. Even if you write 0 also, no problem. After 0, wherever m is present, return me that, okay. So I can write, even if you write 3, then also I am saying that after index 3, wherever the first m you get, return me that m. That is the concept. So if I write 1, 1, 2 or 3, then what will be the index value of m? What will be the index value of m? So after index 1, where is m present at index 4? So the value of I will be 4. If it is taken, I am just saying that if this is another argument where I am sending the index value, I am saying that after this index, wherever the next this character is present, okay, if you write here y, then it will return -1, because y after 1, after index 1, no, sorry, here is another y present, right? So it will return that index. After index 1 in country another y is present, right? So it will return that index. But see, it is not capital Y, it is small y, so it can throw -1. If you write here capital Y comma 1, it will return -1. Say if a country had been in capital letters or in uppercase letters, because Java is a case sensitive language. The uppercase lowercase things matters a lot in case of Java. Okay, so if you write, if you are searching for y, and if you are writing y comma 1, if country is in capital, I mean whole word, and y is present in capital form in it, so then it will return the index of that y. Okay, just count it, and in comment section let me know what is the index of this y. So that will be the value of I. Fine. So now if I talk about m, so what will it be? It will be 4. It will be 4. Right, as simple as that. Now what I want is, I am searching, if I write here index of z, int I is equal to index of z, what will the value of I be? Just pause the video and think for a while. So ready? If I go through this sentence, z is not present anywhere. Z is not present anywhere. Yes or no? That means z, as z is not present, it can have no index. So at that point of time, it will return -1. So value of I will be -1. So this -1, if index of is throwing -1, that represents the character is not present. The particular character or the word or a word. When I can also give a string as an input to the index of. Fine. So that particular word or character is not present in the given string. Fine. If I am searching for a word, say if I am searching for country, okay, if I am searching for country, what can be the index of country? See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Right? 18. So, if I am talking about country, so country is altogether a word. Right? So, which index should it throw up? 14, 15, 12, 13, all are under country. So it will give you in return the index of the first letter of that particular word, first character of that particular word. So it will give you 12 as your output. The value of I will be 12. Okay. And same thing if you write str comma ind, here see no another country in this present is in the word. Okay. So if I write two sentences in a single word after full stop, separated by full stop, say Myanmar is a country, and then if I write, okay, Myanmar is a country, and if I say full stop and then write Myanmar is beautiful, so then Myanmar is present twice in the sentence. So if you at that time mention that, say I am writing here, I am showing you, if I write also Myanmar in the same double quoted as Myanmar is beautiful, in that case if I write Myanmar ind, I mean ind means any specific index, So Myanmar, comma 7. So after index 7, wherever next Myanmar is present, it will throw the index of the first occurring character of that particular word. Just find it out and let me know in the comment section. So that was the concept of dot index of. Now another function we had is caret. Okay, caret. So these are just the basic concepts, and in the upcoming lectures we'll be considering some programs related to strings. Okay, dot caret. See these, but the names are also easy. From the names you can just say what the thing is. Dot caret, and it will accept an index. Okay. So what do you think? What can it be? It is a short form of character at, right? So caret. So it will return the character present at that particular index, at the given index. Yes or no? And it can accept only one argument. Okay, it cannot accept more than two arguments. So if I write, so if I am writing a string, say s is equal to origin, fine, char ch is equal to, how to write it, s, because the variable is s. So s dot caret of 0 1 2 3 4 5 caret of 3. So 3 is the index value. Caret of 3. What should it return? Absolutely, you are absolutely correct. So caret ch is, the value at ch will be j. Yes or no? The value at ch will be j. So that was all. C caret. Two uppercase I have discussed, two lowercase, dot index of dot caret. Okay. So this was the thing. This is how a program will work. Okay. And now what is more left? And we have certain comparison functions. So anytime you can return, if you write here caret of 1, okay, caret of 1, so it will return you r. Okay. And naturally caret returns a character data type, as you can see. It can return only one character at a time. It cannot return a string. Okay. Okay. Another function we have that I forgot to mention is substring. Is a substring. Dot substring. Dot substring. Okay. So say I am writing I am a teacher. I am a teacher. I am a teacher, and say I am considering a dot substring. Dot substring has an ability to accept maximum 2 indexes, can accept 1 index also, can accept 2 indexes also. So what will it do? By as the name suggests, it will bring out for you a substring. Okay, a substring for you. From this whole string it will bring out a substring for you. I mean marking the indexes 0 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, if I am writing string s is equal to, I mean s1 is equal to s dot substring 5. Yes or no? 5. So if s1, I am storing in s1, if string s1 is equal to s dot substring 5, that means it will point at index 5, point at index 5, and it will return the entire string up to the end, continuing from index 5. That means S1 will return our teacher, our teacher. It will have our teacher as its string. Yes or no? Our teacher, our teacher. So S1 is equal to S dot substring 5. So 0, 1, 2, 3, 4, 5. 5 is the, I am marking it with another color. So I am marking it with red. So 5, from index 5, this entire string will be collected. Getting my point? Yes or no? So, and if I am going to write, say I am just using this for a while. If I write string S2 is equal to S dot substring say I am writing 2, 4. What will it do, you think? So it is sure, as the starting index is 2, it will start reading the string from index 2. Okay, I am marking it with green. Okay, another color for your betterment. So it will start reading it from 2, and now it will collect all the strings up to the last index minus 1. So here if I am writing 4, it will collect the string up to 3. 4 minus 1 is equal to 3. Okay, so it will collect m. So if I am writing 2, 4, it is collecting m. So S2 is equal to m. Fine, S2 is m. Okay, and S1 is our teacher. S1 is our teacher. So index and then index 2, whatever you have taken, so index 2 minus 1. Basically I am saying actually, so up to 4. So up to 4 means before, just before 4 you are stopping. That is why. So as like say when I am giving the 5, by default what is happening, 5, when I am writing only 5 comma the length of the string, if I say from 0 to 13 is 14. So internally what is happening, 5 comma 14. So 14, 5 comma 14 means from 0 to 5 to 13, 14 minus 1, that means 13. Up to 13 it is collecting the whole thing. And so same thing is happening here when I am passing separately index 2. So I am writing 4, that means 2 to 4 I am writing 4 minus 1. So 4 minus 1 is 3. So 2, 3, it will be collected. Okay, basically it is slicing. If string is a long string, if you consider it like a thread, like which you tie up somewhere, so I am just slicing some portion of that thread. Okay, mentioning the indexes from where to where, slice it. Okay, so that was all about today's lecture. These were the basic things about the string. In the next upcoming video, we'll be considering a program. We'll be writing programs of using string, and in the next video, we'll be discussing string buffer class. Okay, so that was all about today's class. Thank you guys. Hope you all doing well. Okay, and also we will be doing some comparison functions related to string. So just note it down before ending today's video. I am just mentioning the functions, comparison functions of string. Just note it down, which I will be discussing in the next videos. Comparison functions. These are basically like relational operators. So dot equals dot equals ignore case, dot equals ignore case, dot compare to, dot compare to. Okay, so these three, mainly these three. Okay, so note down these functions or take a screenshot of it. These things will be discussed in the next upcoming video in my lecture. Okay, so till then, bye bye, take care, have a good day.